Sorry. I was sorry. Don't yell at the president, though. So what can we discuss? I don't have any particular agenda, but I would be happy to go over anything that you see on the sheet. I don't want to do exactly the ones on the sheet, but I will make up another one. Leave these for you. Usually I hand out the answers, although most of the answers are like pictures, and rather than print that all out, I am going to post the answers on our website so you can check them out. What do you want to talk about? Yeah.
Can we do one of the repeated nearest neighbor algorithms?
Repeated nearest neighbor, sure. Maybe, actually, could we just do maybe the one that was on the quiz, just so that I don't have to invent one out of nowhere? Let's try, oh, not that one. Not that one. This one. Let's try this with the repeated nearest neighbor. This one is, the repeated nearest neighbor is slightly annoying to do just because you have to, do the same thing repeatedly. But in my opinion, it's a little bit more interesting than the brute force, which is just totally sort of brainless. I mean, you have to make sure you're adding the numbers right. Anyway, the repeated nearest neighbor. So what that means is we do the nearest neighbor starting at A, and then we do it again starting at B and C and D, and we choose the best one that we get overall from all of those different choices. So starting from A, I hope you remember how to do the nearest neighbor. This is what we talked about last time. Starting at A, I have 3 options, and I just pick the cheapest one, which would be the 2. So I go A to B, which is 2. Then from B, my 2 choices are go diagonal for 4 or straight down for 1. I take the 1 going down. So this is B to D then for 1. And then across the, well, now since I've already gone across the top and down the right side, actually to make a Hamilton circuit, I have to go across the bottom and back up the left side. So that will be C next, that's for 1, and then back to A for 5. So this is what I get doing the nearest neighbor starting at A. And this will add up to 2 plus 1 plus 1 plus 5 is 9. Actually, I know because we did it on the quiz already. That is the best one, but we're going to imagine we don't know that yet. All right, so that was starting at A. This is what I get. Starting at B, what do we get? So this time I start with B, and I do the same thing. The nearest neighbor means I'm starting here, and then I take the cheapest option, which will be down to D. So this will go B to D for 1. And now when I'm at D here, I have 2 choices, the 1 or the 3. I take the 1 because it's the cheapest. And then I must finish from there. I started here, I went down and then left. I have to go up and then right to make a Hamilton circuit. So that would be to A and then to B. That's a 5 and a 2. Actually, this is the same circuit, just starting at B rather than starting at A. It's still going around the outer square. All right, that was B. Do this for C and then also for D, and we'll be done. So for C, I go C. From C, I have to take the cheapest option, which will be the 1 across the bottom. So it'll go C to D. And now from D, I take the 1 again. That's the cheapest option from D. So this will go up to B. And then I have to finish by doing A and C. I hope everyone sees how I'm doing this. This one is, again, the same circuit, going around the outside, this time in the opposite direction, and starting and ending at C. So that's also a 9. And then finally, starting at D. Actually, when I start at D, it's somewhat ambiguous because starting at D, I have a tie for 1 in either direction. Probably on the test, I will be sure to make it so that there are no ties, just so that you don't have to make a choice on your own. But in this case, all you can do is just kind of decide for yourself which way to go. Just to make it interesting, let's say I'll go left first. So I'm going to go D to C for 1. And then from C, my choices are up for 5 or diagonal for 4. I'm going to use the diagonal for 4. And then to finish off the circuit, I've already done this. To finish off, you have to go across the top and then down the other diagonal. So across the top would be to A for 2, and then down the diagonal back to D for 3. This one adds up to 10. All right. So that's the repeated nearest neighbor. I just do all of them with each different starting point, and then you choose the best one out of all the ones that you found. And in this case, we have a tie for 9, but it's, you know, any one of these, they are all the same circuit. They're all going around the outer edge. You can decide for yourself how you want to choose the answer, but this is the best one. I would just say, yeah, it's tied. So really, you could have chosen any of those 3, which gave us 9. Does that look good? Yeah. The nearest neighbor is, for this one, I would say is not much different from what you did on the quiz. I mean, it's a different procedure. I mean, it's not much easier or harder. But for a very big graph, the brute force would take you forever, but the nearest neighbor is much more efficient. That's the point of it. What else can we discuss? Yeah?
We do an example of the sorted edges.
Yeah, you want to just try the sorted edges on this one? This one is not terribly interesting because it's so small, but yeah, let's just try the sorted edges here. Maybe I'll paste that. Yeah, I still got it. Paste that picture again. The sorted edges, that's the one where you write down just all the weights in order of all the edges you got. I see a 1, I see 2 1s, a 2, a 3, a 4, and a 5, right? And then you choose those edges in that order as best as you can. So I'm going to begin by choosing the 1. Now there are 2 1s actually. I'm going to end up choosing both of them, but that's here and here. Again, if they're ties, you sometimes will have to just make a choice yourself. Although on our test, I'm going to make it so that there's no ties. All right. Anyway, I begin by choosing those 2 1s. Next, I would like to choose the 2, and you just have to, you know, that's here. You just have to ask yourself, is this legal at this point? Legal means it doesn't make a 3-way intersection and it doesn't make a subcircuit. And I think this is legal at this point. It does not make a 3-way intersection or a subcircuit. So yes, I take the 2 next. Next is the 3. Can I use the 3? That would be this one. The answer is no, you cannot use the 3. If you took that, it would make a subcircuit, this triangle. It would also make a 3-way intersection down here. So do not use the 3. What about the 4? For the same reason, you cannot use the 4 here, because that would make a subcircuit and also a 3-way. Do not use the 4. Can I use the 5? Yes. The 5 finishes it off. So my answer here. And now when it comes to writing the answer, you can write it as if you started anywhere. And on the test, I might say, use the sorted edges and give me a circuit which, let's say, starts and ends at B. So then I would write it starting at B, go around the outer edge. And again, there's 2 choices. You could go around sort of clockwise or counterclockwise, and either one is acceptable. I'll go clockwise, B, D, C, A, B. And this adds up to 9, although if I didn't ask you to write the total, you don't have to write the total, I suppose. All right, this was the sorted edges. Any questions about that one? What else should we do? Yeah?
I have just a general question. Is
Sure.
it incorrect to say that brute force is always going to be the corners, like the going all the way around?
Brute force is not always going to do. You mean on this example? It would. But ordinarily that's not true. I think the reason it happens in this case is because if you just look at the numbers around the outside, I see 1s and 2s. I mean, the 5 is not good. But the diagonals are fairly heavy in this case. So in this particular example, to get the best one, you probably want to avoid the diagonals and stick to the outside. But that's definitely not true. If I change these numbers to, like, 15 and 100, then definitely going around the outside is not the best way to do it. Yeah?
Can you do a minimum duplication circuit?
Sure. Minimum duplication circuit. You want to try the one from the quiz again? I'm into recycling here. How about this graph? Let's find a minimum duplication circuit. just because you got it on your paper already. Let's find a minimum duplication circuit. Circuit for this graph. All right. Anybody remember how should we begin this? This is quite different from Hamilton circuit, so I hope you can remember. What should I do first? Look at the degrees. Yeah, actually, that is usually what you want to do, even for Hamilton circuits. You also look at the degrees. The minimum duplication circuit. Look at the degrees, and I have a particular eye for the odd ones. That's what's going to matter when you're doing the duplication type stuff. So I see 3s here, 2s on the corner. For Hamilton circuit, 2s are very important. Not so really in this example. For duplications, really what you care about is odds. Oops. That's a 5, that's a 3, a 3, a 3, a 3, and a 2. Those are my degrees. I hope you are an expert by now at determining the degrees. Unfortunately, if you screw up those degrees, you will be screwed for the rest of the problem. Now, what do we do? For a minimum duplication circuit, let's decide first of all which edges am I going to duplicate. And what you want to do is focus on the odds. Those are kind of like the bad ones. You basically want to turn all the odds into evens. And you do this by duplicating existing edges. And it's best if you can just pair up the odds, pair them up 2 by 2, and duplicate an edge in between each one. And I think that is possible in this example. For instance, the 2 3s on top, I'm going to join them up by a new duplicated edge. That will turn each of these 3s into a 4, which is good. I want them to all be even, right? How about the 2 3s on the left side? I'm going to join them up also. Now these are both 4s. Can I pair up the remaining ones? I think so. These 2 in the middle on the bottom, these 2 in the middle on the side, and then I can go diagonal for those 2, right? If I pair them up in this way, there are other ways that you could have paired them up, although, yeah, there are other ways you could have done it. I think, I don't know, actually, there may not be another way to do this in a way that they all match 1 by 1. Anyway, those are the edges which I will duplicate, all right? If I wanted to make life easier for you on the test, I might just say something like, tell me which edges you might have to duplicate if you drew a minimum duplication circuit. In that case, you could stop right now. According to what I've got so far, I'm going to say 5 duplications will be necessary, right? If I wanted to make it an easier problem, I might just ask you, like, how many duplications are you going to need to do a minimum duplication circuit? But if I say find a minimum duplication circuit, you can't stop here. The next step is to actually draw in the circuit, which covers every edge and duplicates those 5 edges as I indicated. So maybe I will start with a fresh picture here. I know that's a little inconvenient for you all to do, but the edges I'm going to duplicate, I gotta go, will be here, here, no, here, and here, right? And I'm going to draw in my circuit. Please draw your circuit in a way which is legible. I wrote that on the review sheet. Make sure your paths are readable. Several people have been losing lots of points on our late homeworks and quizzes because you're still drawing paths and circuits which are impossible for me to read after the fact. I am going to start, since I'm drawing a circuit, I can start wherever I want. So let's say I'll start up here. And I'm going to draw a long, winding path with some arrows. Let's say I go like this. I will reiterate my pro tips for drawing a readable path. First of all, do not draw your lines right along the edges of the graph, because then I won't be able to tell where they go from one step to the next. And do not draw your lines right through the vertices. Make it go kind of next to them. Leave a little room for the Holy Ghost, as they say. If you draw right through the edges and vertices, then it's not possible for me to tell what you are talking about. All right, and another little pro tip. This is for the true pros out there. Draw your arrow in the middle of the edge rather than right by the vertex. That's because things get a little crowded by the vertices. It's much easier to read after the fact if you draw your arrows kind of away from the vertices. Anyway, let's just keep it going here. I'll go around that one. Whoa, sorry. Drawing on top of pictures on this thing, it scrolls like crazy. All right, as I'm going, I am trying to keep in mind what I do. I messed it up. As I was saying, as you go, you have to make sure, keep in the back of your mind, where are all the edges remaining to cover? And you don't want to split them apart in two, which is what I just did as I was saying that. At this point, the edges I have remaining are these up here. Come on. These up here, right? The three across the top, plus that one. And then a whole lot down here. Now, if you go up at this point, you will never be able to get back down here because you will have cut that off. So don't do it. I just did it. Don't do it. Let's try and go cover all these guys down here. I'll go across like this. Like this. How about up here and down this one again? That's one of my duplicates. Around this guy. I think I'm doing okay here. This one I will go across and come back. This one back down here. All right, I'm feeling good now. That's how I do it. That is a minimum duplication circuit. All right. Any questions about that? This kind of thing really requires a lot of practice, I would say, if you're feeling nervous about this sort of thing. I tried to give you a lot of ones on the review sheet there for you to practice with. So I hope that makes a little sense. Can I give you a little "don't do it this way" example? I've said this many times before, but I still am seeing things like this on people's quizzes. I see people drawing things like this. I'll go like that, like that, like that, like that, like that. This was a duplication though, so maybe I'll also come back this way. What I'm talking about, this is why you should not draw it right on the edges. I can tell just because you put a big dot that you started here, but once you go down here, now I don't know what happens next. Did you go to the right next or did you go down next? There is simply no way of knowing because you drew your edges right on top of the existing edges and you didn't connect the lines like over here. I can definitely tell where it goes at the vertices. All right. Some people, sometimes I see something like this. Here's just one last example of don't do it like this. Some people remember I said don't draw it right along the edges, so they're like this. Okay. I'll do it like that, and then like that, and then like that. And they eventually end up filling in all of the arrows. But this has exactly the same problem. For example, I can tell you go down and then to the right, but now do you go up next or down next? Ain't no telling. There is no way to tell because you drew like disconnected arrows. You've got to actually make them connect together like that in order for me to know. If you're ever wondering, I mean, you should be able to look at your own picture and ask yourself, does this make any kind of sense? If the answer is no, then draw it again. That's why I usually give you 3 versions of the picture. All right, that was minimum duplication circuits. Can anybody say, what if I ask for a minimum duplication path? It's very similar, but with with a slight difference. What would be the difference in that case? Yeah.
You need to leave two odd edges.
Right. Yeah, when you're doing this step, when you are doing a path instead of a circuit, you leave 2 vertices odd, make the rest even. And then when you actually are drawing it, you have to start your path at one of the odds and finish at the other odd. That's the difference. All right. Yes?
Can we still reach out to you about averages?
Yeah, sure. I have been emailing people about their grades overall. I'm happy to continue. If you want to play some games about what do I have to get on the final to get this or that on the grade, we can play some games. It's all in a spreadsheet, so it's very easy for me to answer such questions. How about this? What about in this question? What if I said find a Euler circuit, or say that it doesn't exist? What would you say? Anyone remember what that's all about? It doesn't exist. Why not?
Because there's more than 2 odd answers.
Yeah, remember the rule for Euler is Euler circuit requires all evens, and Euler path requires all evens except for 2 odds. So you can't do either in this case because they're not all even, so you can't do an Euler circuit, and they're not all even except for 2 of them, so you can't do an Euler path. Great. What else shall we discuss? Yeah.
Would we draw the Euler circuit?
Draw an Euler circuit, sure. So that graph doesn't have an Euler circuit. I will have to invent one which does. Maybe I'll try and make a big one here and have you guys try it out, and then I'll walk around. I find that these ones, especially the circuits, the duplications and the Euler, it all seems to be pretty simple when you watch me do it, but it's a different matter to try and do it on your own. So maybe we'll try one all together. Sorry, I'm just trying to make up a good one. Yeah, that's a good one. Find an Euler circuit. And draw it good for me. Making a circuit so you can start and finish wherever you want.
Mark? With your picture. Another block there.
That makes sense.
That's impossible, because that would be.
Yeah, I was, okay.
Good.
Looks like people are doing pretty well. I'm gonna do my answer. My answer will likely look totally different from yours because there's so many different ways that you could do this. Well, there's my answer. As I was going around, it looked like people were doing pretty well. I'm not sure I have a lot of advice other than how to draw the picture legibly. Look at that! Look at that arrow. It's not a good arrow. Look at that. Like this. The arrows are not actually all that important. People are never really ambiguous with the arrows. It's where the lines go. It's hard to read sometimes. All right. What else can we discuss? Maybe have we already talked about everything on the paper? Maybe. Can we? How about let's do the same graph but find a Hamilton circuit, or say it doesn't exist. I actually don't know what's going to happen. So it looked like this. Let's try to find a Hamilton circuit, or say there is no Hamilton circuit. Now this one may be, you have to guess, I don't know. For that, this is what you should have done on the quiz today, right? You should begin by choosing the even degree edges. Oh, I can tell what's going to happen immediately. The even degree edges are all the outer corners, right? They are all evens. So you have to use all the edges around the outside, because every one of those outer corners is an even degree. Like so. Now what? Am I done? Eliminate the three ways. This is a good thing to do ordinarily after you scribble in the degree twos. Although actually in this example, I think you don't even need to go there. Anybody feel like there's something else you could say at this point? I feel like I've already made a circuit, right?
Yeah, you try to get the vertices beside it.
Yeah, like, so one thing to say this is, since I've already made a circuit, there's no way to pick up those vertices also without making a three-way somewhere. Although I think there's actually a cleaner thing to say here. Would you believe me if I said that is a subcircuit, right? Usually we think of a subcircuit as being really small. This is kind of big on the picture, but it is a circuit which doesn't use all the vertices. That's a subcircuit. So after filling the degree twos, so the twos forced a subcircuit. That big outer cross there that you see in red is a subcircuit, because it is a circuit, but it doesn't use all the vertices. All right, the 2's forced a subcircuit, so ham is impossible. No Hamilton circuit in this graph. Anything else to discuss? I think we have done one of everything. Maybe we'll leave it at that then. We had another 20 minutes, but you know what I got? I got some ham in my office actually for lunch. So, no pun intended. Please let me know if you have more questions come up. You know, it's quite a long time till the exam, so let me know. And if you want to know about grades, I can do that too.